As Dan, all right, continue. As Dan said, I am a college professor, and I've always felt that my calling has been always to make lifelong naturalists or lifelong scientists. Of course, students take all my courses for the sake of a letter grade, but my ultimate goal is to make at least a few lifelong naturalists or scientists. So to that end, I do anything that I can. I think one of the things that has always worked for me is do short research projects with students, undergraduates, and if possible, high school students, and give them the thrill, the joy of scientific inquiry, make them own a project. And if ultimately it leads in a publication, that's icing on the cake. So that I've strived to do that over the past few decades. One other thing I do in my global wanderings is to try to get local people involved in projects so that they can take ownership. After all, they are going to be stewards of the planet, of their country, of their habitats. I'm going to be there just for a few days and then I come back, but I'd like to leave something behind. So in the next 45 minutes or so, I'm going to give you a nice tour of the world. I'm going to take you to 3 countries. First stop would be this little island, Bermuda, up in the North Atlantic. And then I will take you to Belize, a small Caribbean nation at the base of the Yucatan Peninsula in Mexico. I've taught a study abroad course there for 11 years consecutively, except for last year for obvious reasons, and this year, of course. Hopefully, we should be able to resume it next year. And then I'm going to take you to Sri Lanka, a joyful island south of India in the Indian Ocean. As Dan said, I got stuck there. But first, let me talk to you about Bermuda. This project was done for the sake of a 16-year-old girl. At that time, she was 16, a couple of years ago. She lives in upstate New York. She wanted a project. Actually, she wanted to study rhinoceroses or something, or conserve rhinoceroses. I told her, I cannot give you a rhinoceros, but I can give you a real cute bird, highly endangered, and you can study it from your bedroom or from your living room. And she grabbed the opportunity, and here we are talking about. So Tara did this project, spearheaded the project. We helped her in the data collection. Bermuda is this little island in the North Atlantic. It's really geologically not part of the Caribbean. It's out in the middle of nowhere. It has the shape of a fish hook. And it's really an archipelago of several dozen islands. But the project that we're going to talk about originated here in this little island called Nonsuch Island. It's a tiny, Bermuda is full of these rocky outcrops outside of the main island. The Bermuda petrel ranges far and wide in the North Atlantic. It goes all the way to the British Islands, off the coast of Spain and Portugal, and it goes to the Caribbean in the south. But Bermuda is somewhere here, right? But it has all this real estate that it wanders, but it only nests in Bermuda. And that's the problem. It seems to have put all its eggs in one basket, almost literally, right? It is a stunningly pretty bird, not bad for a petrel. Petrels are usually not that striking in appearance, but Bermuda petrel is quite an exception. It's also called a cow because of some eerie call that it makes. It is one of the rarest seabirds in the world. It was driven almost extinct by pigs and rats that humans introduced. Around 1492, when Christopher Columbus sailed past Bermuda, as high as 500,000 pairs of Bermuda petrels were nesting in that island. But within 100 years of the advent of humans, thanks to the pigs and rats and whatnot, we drove it to extinction. It vanished for 300 years. For 300 years, it was thought to be extinct. And then it came back. In 1951, it was rediscovered in a little rocky islet outside the main island. It turns out that the birds had somehow hung in there after being wiped out of the main island of Bermuda. Since then, an aggressive restoration program has helped the population. DDT that humans used in the 70s didn't help. It created some eggshell thinning, so that set back the program a little bit. But concrete artificial burrows have been successfully used. Today, it's one of the conservation success stories. It's a spectacular conservation success stories because last year, 134 pairs nested, and this has given rise to some guarded optimism that maybe the species will be saved from extinction. One other problem this bird faces, believe it or not, it faces stiff competition for nest burrows from, you're not going to believe this bird, the white-tailed tropic bird. This is an exquisitely pretty fairy-like bird that drifts above the ocean outside of Bermuda. The Bermudians are very proud of this bird. It shows in their currency. It shows in their posters and their brochures. They're also proud of their Bermuda petrel. It's kind of an awkward situation. They're so proud of two birds, but these two birds don't get along. This tropic bird usurps or steals the nest cavities or nest burrows of the Bermuda petrel. In some years, nest mortality has been as high as 75%. But I just told you that this is a spectacular conservation success story. Well, just guess how they solved this problem of the white-tailed tropic bird. They installed these filtering devices. See that? The biologist is handling a filtering device. It turns out that the tropic bird is slightly larger than the petrel. And so when this baffle or filtering device is put on the nest entrance chamber, in the nest entrance, it prevents the tropic bird from entering, but it allows the petrel to enter. Very much similar to what we did with the red-cockaded woodpecker in the Washitas. We put all these restrictor devices that kept away the pileated woodpecker. But in that case, the pileated is much bigger than the red-cockaded woodpecker, right? In this case, the difference isn't that much. So it is very commendable that these biologists were able to make it such a resounding success. So this is one of the artificial burrows that the biologists made. It has an entrance and a pretty long tunnel, and that's the main chamber. I hope you can all see my cursor. That's the main chamber. So what the biologists do is they can open that main chamber from above, and they can use this as like a service entrance, to measure the eggs or the parents, or to service the batteries and the video camera and so forth. Well, this is the view we had for 167 hours. You're not supposed to see anything. It's supposed to be pitch black, pitch dark, but thanks to infrared camera that Cornell put in, we can see everything that's going on. In the background, you see a dark tunnel. That's the entrance tunnel. Obviously, it's nighttime. If it is daytime, you may see some daylight filtering through, like you do here. So this was taken in the daytime. Most of the time, the bird was by itself. There was only one adult. Occasionally, there were two adults. Both the parents were together. Notice that it looks pretty striking. Dapper-looking fellows. They're also known for these tube noses. See that tube on the top of the bill? That's what this whole taxonomic order of seabirds are known. They're called tube noses because of this tube in the nose that helps them excrete salt. Uh, uh, if you want to excrete salt, you don't want the salt to get encrusted right on your nostril. That'll clog your nose, right? So they let it run for a few millimeters, and that's what the tube nose is an adaptation for. So our webcam study is the first of its kind. The incubation behavior of these petrels is difficult, I would say impossible to study because they are burrowing and they are nocturnal. How in the world can you study something that's nesting so remotely in a burrow and in the dead of the night? But the advent of webcams afforded a great opportunity to fill this gap in knowledge, which we strived to do. 10 years ago, Non-Such Expeditions, a Bermuda-based tour company, installed a live camera inside one of these burrows. Infrared video was live streamed 24/7. Cornell got involved 5 years later, and since then they've had a great collaboration going. We got a lot of cool data. For example, we were able to document that both the parents contributed equally to incubation. It's almost, they measured it, right? They kept track of it themselves, 41 each. And there were times when both of them were together when the egg was present. And there were times when we didn't know the sex of the parent. That's what this U stands for. Male and female they look alike. We were only able to tell the gender based on the local biologist. He made repeated postings in Twitter, whether it was male or female, because they would go through the service entrance and grab the parent and weigh it. And the parents apparently didn't mind. You know, they would release the birds back into the entrance cavity and they would scurry back into the chamber. We were able to quantify various aspects of the incubation behavior. For example, we found that most of the time the birds were resting. That's 56%. And about a third of the time they were sleeping with their head tucked backward. Training lasted a small fraction of the time. Nest maintenance lasted a short fraction of the time. Only 2% of the time the birds were awake. So very high attentiveness. At least one parent is on the egg 98% of the time. That's what A means awake. So we were able to quantify aspects like that. Parental orientation, that's another thing we were able to do. The camera is here, right? And that's the nest chamber. Most of the time, see that? Most of the time, the parents were facing the burrow entrance. So the birds were facing away from us. And I think we know why. All kinds of creatures come in through that tunnel. I mean, we saw land crabs. We saw the critically endangered Bermudian skink coming in. We saw cellar spiders come in. But perhaps the most interesting visitor was a leech's storm petrel. It's another species altogether. The leech's storm petrel would come in, just hang out. They wouldn't harm each other. They would sometimes, peck at each other, but that's it. The leech's storm petrel would come and just sleep in a burrow with an egg of a Bermuda petrel and with at least one parent of the Bermuda petrel. But perhaps the most disturbing intruder was recorded last year, I believe, not during our study. Another adult Bermuda petrel came and he tried to kill the baby. The baby pretended to be dead and somehow he gave up and left. So that was disturbing. There's a lot of competition even among Bermuda petrels. We quantified such things as the rate they shake their head. These tube-nosed birds, they shake their heads, they spasmodically keep shaking their heads all the time. And we think it's because they want the salt to run down the tube nose. And we were able to quantify such aspects of behavior that we may not have been able to without these webcams. Phenology, what percent what was the extent? The male was in the nest versus female. Male is in blue, female is in pink. As you can see, they were together only for about a week in January. After that, it was either just a male or just a female. The black areas represent when, times when we could not tell the gender. Okay, 69th day, the parent.
Go ahead and everything was fine.
Oh, he hadn't seen the message? Yeah.
69th day, the parent buried the egg. The egg was non-viable. The egg was spoiled. The egg failed. The normal incubation period is 55 days for Bermuda petrels. So the parents didn't give up for 2 more weeks. For 2 additional weeks, they kept incubating the egg. And then on the 69th day, they gave up. I'm going to show you a short video of a remarkable film clip that we were able to obtain. The actual process of the parent burying the egg. As you watch this, I want you to look for 2 things. One, it uses its breast to push grass fibers into the nest. 2, it uses its feet to kick backward and fling grass fibers over its head onto the egg. So it's quite remarkable. Watch. There is no audio here, but you may hear me speak. So it just pushed a batch of grass fibers with its breast. And now it starts the kicking. It did that quite a lot. And then it would go out and get some more grass. And you're going to see it push with its breast again, using its body as a piston. So that was sad. I mean, 69 days of incubation, it just buried the egg and left for good. I believe it's good for the bird. That's what the local biologist says. Every 5 years or 4 years, this happens so that they can replenish their energy reserves and come back with renewed vigor the next breeding season. Okay, let's see. I'm trying to advance the slide. Just bear with me just a moment. All right. So what makes this study unique? Of course, we never had to go to Bermuda. We were thousands of miles away. We've never seen the bird in person, yet we were able to get all this data from the comforts of our offices. If this gets published, it'll be the first of its kind. We've offered it for publication to the Journal of the Arkansas Academy of Science, and we are expecting to hear from them anytime. Tara got a lot of mileage out of it. She's headed to Penn State in just a few days. She was able to market herself using this project among her other accomplishments. All right, let's go to Belize. This cool project was done by a local high school student, Haris Rana in Fort Smith, along with my undergrad student, Sheila Smithson. Both of them came to Central America with me. Sheila took my Belize course in summer, and that's how this project materialized. First of all, you know where Belize is? If you don't, there it is at the base of the Yucatan Peninsula. It's a small Caribbean nation, the size of New Jersey. Some background information. These are fungi called marasmias. These rhizomorphs or roots, they commonly form these mesh-like nets, aerial nets in tropical forests. They have been frequently observed in neotropical bird nests, but around the world, nearly 100 species of birds use these black fibers as nest material. These nests are often placed very close to a wasp nest, and that's well known among neotropical birds. You see all the wasps on the nest. But sometimes the nests are also on ant acacia swarming with these nasty ants. So this alone, this is just in one snapshot, you get an idea of how complex tropical interactions can get. You're talking of 4 species here, right? You're talking of a plant, the acacia, a wasp, and you're talking about a fungus, and of course, a bird that uses this fungal material for its nests, all in one complex interaction. The yellow olive flycatcher commonly uses these black fibers. This is a great photograph taken by our own David Oakley. I can imagine this is not an easy photograph to obtain because the yellow olive flycatcher is very unobtrusive. You get to know of it mostly by its calls. Its calls like, a hissing, high-pitched double note that it utters all day long. And once you get to know the call, you know the bird is there. But it's very hard to get such a view that David got. So why are these black fibers preferred? There are a lot of hypotheses. One of them is it may have some antibiotic properties. And I had a student who studied it. She came to my Belize course. She took some samples to Fayetteville and ran some assays, and she found out that it does not have antibiotic properties. So I'm not going to talk much about that project now, but that's what she essentially found out. There are other hypotheses, like maybe they are longer, or maybe they are more water resistant. There is some evidence for that. But we tested these 2 hypotheses. 1, they are stronger than grass fibers. 2, they provide some advantage in the control of temperature. So this is what we did. Harris was able to get these fibers and take them to the University of Arkansas Little Rock. He got a summer research program in a nanotechnology lab. They had this machine that would keep stretching these fibers until they snapped, and they would find out the snapping point. So we compared these black fibers with grass fibers from an oriole nest from the same area. We needed something to compare with, so we chose a bird which uses grass fibers from the same area. And well, guess what we found? We found that the grass nest was stronger than the black fiber nest. So it was the opposite of what we expected. Our hypothesis was the black fiber is probably stronger. Nope. As you can see, the grass nest was much stronger, significantly stronger than the black fiber nest. We also compared nest interior temperatures of the 5 Maraspians nests, the black fiber nests, with the control grass nests. What we would do is we measured the nest temperature and the outside temperature. It was very easy to do. We suspended these nests in small trees, and we put these little data loggers. They are the size of a quarter, and you just sneak it inside the nest, and it automatically records the temperature every half an hour for 2 days or 3 days. And it downloads the data into your iPhone, and it even gives you an Excel spreadsheet. So convenient. I was almost jealous when my students did it so easily, because back when I took advanced ecology in Doug James's class, we had to do a similar project where we had to monitor the temperature of different parts of a tree in Fayetteville. Oh my goodness. We had to climb the tree and wire and connect long wires from the spot on the tree to the device on the ground. And we had to fire up a diesel generator all night long. And that involved a lot of effort, but this is child's play in comparison. Well, guess what we found? There was some temperature benefit in the nests compared to the ambient environment, but there was not much difference. There was not significant difference between the grass nest and the black fiber nest. Both of them did afford some benefits, but the amount of benefit was not significantly different. So we rejected both the hypotheses. But we hope that our study should spur future inquiries because we use some pretty cool methodologies. We've submitted this paper to the Journal of Arkansas Academy of Science. Harris got a lot of mileage out of it. He became a Bodenheimer Fellow, and he's starting his biochemistry bachelor's degree in just a few days from now. So these things do take you places. All right, let's go to Sri Lanka. 13 months in a tropical paradise. Yes, my wife and I arrived in Sri Lanka in February of 2020. We were supposed to be there for 6 months. COVID had other plans. A month after we arrived, the pandemic started. We got stranded. There were no flights for a long time. And when flights did resume, it was dangerous to fly. And there were other reasons why we couldn't budge out of the country. But it was a great place to get stuck. You know, I could not have chosen a better place to get stuck. It was full of birds. We were not in Colombo. Colombo is the capital. We were in Matre, which is a small town on the southernmost tip. Now, Sri Lanka, as you see, is very close to southern India. I am originally from this part of southern India, so I'm familiar. My Hornbill study was done in the Western Ghats. This is a spine of mountains of rainforests running down the western coast of India. Sri Lanka is geographically very similar because, after all, Sri Lanka was connected to India up until the last ice age. It's only been isolated for about 15,000 years. But in that 15,000 years, the avifauna evolved independently. And there is a remarkable level of endemicity in that whole area. In fact, this whole area is considered one of the biodiversity hotspots in the world, one of the biodiversity hotspots in the world. As I said, I could not have chosen a better place to get stranded. That was our house. We were there for 13 months. It was on top of a hill. It had a big balcony, and the balcony was about 120 feet above the ground level. The area was full of wildlife. The temperature was never more than 80 degrees, mostly in the upper 70s, never under 69. Around 68, the local Sri Lankans start wearing sweaters and mufflers, you know, and they were shocked that I would go in my shorts and t-shirt out running. So, aren't you cold? I laughed. You know, there's 6 feet of ice in my Arkansas as we speak, I would tell them. So it was a great place to get stuck. There was a lot of, you know, fresh fruit, papayas, mangoes. We feasted. We really had a good time. Physically, we were fine. Physically, there was not much COVID when we were there. Of course, now the Delta variant is doing some nasty things in Sri Lanka. The view from the balcony was stunning. Rainbows and all. Imagine some whale spouts in the background. I saw whales from my balcony. If you go straight toward the horizon, you'll hit Antarctica, you know, 4,000 miles or so away. You are probably looking at the most studied 4 hectares in Sri Lanka or even in South Asia, because I was stuck there in the balcony. I spent many hundreds of hours in the balcony documenting the birds because I had nothing else to do. On to my right, there was a forested ridge. The sunsets were spectacular, but the ridge was quite interesting. The local people warned me not to go there because that was my exercise route. They said there are some ghosts there. That made me want to go there more. And guess what I found? I found the ghosts. They were brown wood owls. They go, ooh, or ooh, every night. And that probably is the reason why the locals thought there were ghosts there. Lots of wildlife, 3 species of monkeys, including this langur. In my garden, there were these hump-nosed vipers. They were a herpetologist's delight. They are nasty, they are venomous, but fatalities are not known. They would probably send you to the hospital. I had to be a little careful, but they were gentlemen. They avoided us. The beach was 3 minutes walk down the road, and the beaches in Sri Lanka are absolutely spectacular. Some of the best diving sites are just off the beach. Every morning or many mornings, I would go down to see what the fishermen brought. And sometimes I would be surprised, like this spotted eagle ray that a local fisherman is showing off. During the pandemic, there were some lull periods when the lockdown was eased, and we did a pelagic trip that was so memorable. I've done pelagics around the world. This was probably the best. It was a big, comfortable boat. It had a protection overhead, so you don't get sunburned. And the wildlife we saw was amazing. We saw 5 to 6 species of birds, mostly bridal terns, and lots of Wilson storm petrels. But the catch of the day, so to speak, were these two, Swinhoe's storm petrel and flesh-footed shearwaters are rare there. The Swinhoe's storm petrel is a near threatened species. It nests in Japan and wanders down to the Indian Ocean. And so we were happy to see. There were like we saw 4 or 5 species of whales, starting from the smallest, this is a toothed whale, to the largest mammal on Earth. So enjoy this little video of the largest mammal on Earth, blue whale. You may hear the breath of the whale, so you may want to turn up the volume. And I'm going to hold the microphone close so that you can hear the whale in addition to seeing it. Okay, here we go. I hope it works. This came out. It's going to come up again. Watch for the bulbous bulge on the head. There, blue whale, the largest animal on Earth. I was so thrilled. I could also smell its breath, by the way. I don't think they brush their teeth. All right, let's get back to the birds. My dream, when I knew I was going to get stuck there for a year, I knew that I had to meticulously document and quantify the bird life so that 50 years, 60 years, 100 years from now, people can do the same thing that I did and get an idea of what's happened to the birds. See, we take it for granted in North America. We have breeding bird survey, Christmas bird counts, but in the tropics, we don't have such monitoring programs. So I thought, well, if I'm going to be stuck here for a year, let me do that. Let me meticulously document and quantify, put numbers in the birds. So I did 520 stationary checklists. I'm going to refer to them as scans. About 700 in all I made in that 1 year. I spent about 20 minutes per scan because beyond that, you tend to count the same bird again. So I wanted to avoid that. In terms of number of species, this tally is not impressive, but it's the specialty, the endemicity that was so interesting. 103 species in all. I got 200 birds per checklist, about 64 species a month. In the winter, November and December, it went up to 76 because we had all these Palearctic migrants coming from Russia, Siberia, and the Himalayas. I classified my birds as yard residents, birds that I saw in my yard all the time, about 48 species. A lot of birds just flew by, ibises, spoonbills, storks, that kind of thing. They were the transients, 44 species. And there were 11 migrant winter visitors. And one of the ways I characterize the birds is I ranked them from most common to less common, okay? And I used several metrics. One of them was the maximum number seen. I took the median of the maximum number seen. And by that metric, the little swift is the most common bird. I saw about 9 maximum in my census. And then the green imperial pigeon, which is the spectacular fruit-eating forest bird, that was pretty common. I got about 6 of them in my censuses. This exquisitely pretty purple-rumped sunbird was also common. I got 2 pairs or so in most of my counts. And that's the way I quantified. I don't know what that bird is because that bird is behind Dan Scheinman. What bird is that? Oh, Tickle's blue flycatcher. I have this panel of people. Karen and Dan are blocking my view of the Tickle's flycatcher. Move, Karen, Dan. Anyway, the Tickle's, now I see it. Tickle's flycatcher, it nested in my yard. So this is the way. Now, the interesting thing is I used other metrics like birds per hour, average, and I got more or less the same ranking from the most common to the least common. So I know I'm doing something right. And so I hope that this would be a bedrock, a record of the common 30 or 40 species, so that someone in the future may be able to do the same thing and find out what's happening, because birds are good barometers of the environment. One other way I'm portraying the bird life in a monograph that we are working on is, show at a glance when they are here and when they are not, and also what's their frequency. For example, this stunningly beautiful bird called the paradise flycatcher, my wife would just gasp whenever she saw this guy. It's all as though it was created by an artist's wild imagination or something. Notice that the paradise flycatcher comes around October. It's a late fall arrival. And then by January, it's pretty common. There are sometimes like February. If you see a lot of blue, that means 100%. All my checklists reported the bird. The 4th week of February, all my, and then the 2nd week of March, all my checklists reported the bird. It has a distinctive call. So, and it also, it darts in and out of the forest like a fairy, almost like a tropic bird of the forest. And then you have this bird. Lynn Christie is blocking its view, but I think it's a forest wagtail. It's a wagtail. Most wagtails wag their tail this way, up and down, but this wagtail sways its butt side by side, not just the tail, but the whole hindquarters of the body is swayed. So very cute guy, forest wagtail. Notice that he comes in winter around September, but he leaves in December. That's pretty interesting. Maybe he breeds so far up north, Japan and Korea, that he has to go leave that early. Notice that he's not in my property in January and February. So that's the way. And this little guy, the rosy starling, also leaves pretty early by January. They travel in flocks, and I was able to easily record them. But January they were gone. So this is the way I'm characterizing the bird life. One interesting migrant is that guy, the Indian pitta. The Indian pitta is one of the prettiest birds in the world. And it's a bird of the understory. It hops in the ground. It chooses the thickest of the thickets. You can never see it. In fact, believe it or not, I never saw it. In 1 year in Sri Lanka, I never saw it. I've seen it elsewhere, but I badly wanted to show it to my wife. She wanted to see it because we heard it every day. I'm going to play its call. Here we go. It's got a very stunning call. I hope it works. Here we go. We chew, early in the morning, late in the evening. The locals called it, well, in Hindi, it's called Navrang, nine colors. And in my language, which is also spoken in some parts of Sri Lanka, Tamil, in Tamil, we call it Arumani Kuruvi. Arumani Kuruvi means 6 o'clock bird, because it calls at 6 a.m. and again at 6 p.m. And that's pretty accurate. My wife badly wanted to see it. I never could show it to her. Of course, we were 120 feet up, up above the ground, and that didn't help. But I was hoping he would come out occasionally, but I never got the opportunity. She still thinks that it's a mythical bird, like what I feel about the Bachman sparrow, but that's another story. All right. There were 7 endemics in my yard. Sri Lanka has 33 endemics, 33, which is stunning compared, given the fact that it's so close to India, and it was connected to India just like yesterday in geologic time. But 33 species have evolved independently, including a magpie, believe it or not. Why would you have a magpie? The nearest magpie is in the Himalaya. It's nowhere in the main part of India. The nearest magpie is in Himalaya. And yet, Sri Lanka is great for that kind of thing. This was a small bulbul that loved to eat lantana berries in my yard. This was a barbet that stayed on the treetops and was very hard to see. This was a woodpecker. This is a woodpecker called the flameback. It is a common member of the mixed hunting flocks. And this little guy, just the size of a sparrow, is the Sri Lanka hanging parrot. You will never get that kind of a view because he's always in a hurry. Seasick. He's also seasick because you go seasick. They fly about at top speed, saying seasick. Sri Lanka swallows are very pretty. They call loudly when they fly by my balcony, so I was able to get some good audios. And when I uploaded the Sri Lanka swallows audio into eBird, I was the first. eBird did not have a Sri Lanka swallow up until that point. This is a pretty common endemic called the Sri Lanka green pigeon. This was the only photo I was able to get. This is a bird that travels in flocks, can descend on a fruiting fig tree and completely vanish, completely. And then later on, when you completely forgot about it, they would just explode out of the tree loudly. But that was the only photo I was able to get of a Sri Lanka green pigeon. Of course, my favorite, the Sri Lanka gray hornbill. He probably knew that the world's expert on hornbills was living there, so he came to visit me every morning. I call myself an expert because not many people have studied the hornbill, by the way. So in the land of the blind, the one-eyed man is the king. So this guy, this guy came almost every morning. Sri Lanka hornbill, look at that. He was very intelligent. This is a female. She was also curious. And they had the weirdest call. I just have to play that for you. Listen. Is that a maniacal laughter or what? Sri Lanka grey hornbill. One advantage of being in a balcony 120 feet high is you get to see birds nesting at eye level. And I had the fortune of having shikras nested. Shikra is like our Cooper's hawk. It's an accipiter. It was nesting in a platform about 100 feet at eye level. And I would see this shikra dive bomb the hornbills. Sometimes whack, you could hear the physical contact. And the hornbills would make such a racket. But I was wondering, is this an offensive act or a defensive act? Because both are predators. Both are known to eat nestlings and birds. But I didn't have to wait long to answer that question because one day I saw 2 Sri Lanka grey hornbills trying to steal the shikra's nest when the shikra was perched in the nest, incubating. And the shikra didn't give up. It just turned around and faced the hornbills one after the other and hissed and snapped at them. This went on for several minutes. But I noticed that the hornbills were hunting in tandem. One would try to distract the shikra and the other would try to sneak in from behind. So the shikra kept turning around, and attacking the hornbills. Hornbills gave up and went away. So I was able to describe it and publish it in a little note because tropical birds, very few is, we know so much about our birds in North America because there are so many birders, but not much is known about tropical birds. And so every little bit that you contribute is an advancement in knowledge. Another project that we worked on, in fact, we submitted this paper just today. My friend Pavan and my colleague Nisha at the Department of Zoology at the University of Ruhuna, we studied this bird. It's this bizarre bird called the knob-billed duck. It's got a strange story. Long story short, it was never common in Sri Lanka. And then it was described 300 years ago, by British. And then by 1960s, it completely became extinct from the island. It vanished completely. And we didn't know why. People were worried about it. Maybe because of hunting. But 50 years later, it showed up again. Almost like the Bermuda petrel story, right? It showed up, and now it's seen in small numbers. You may wonder why it has that grotesque comb, right? Well, now you know why. Males use it in their territorial displays. They butt heads, they bow, they prance, they walk around in circles, showing off their combs. They flap and they lunge, they mount each other, and they kick each other with their feet until somehow the winner is determined. And we were able to get this a nice sequence of photographs for our paper from our buddy Iroshan. The good news is the knob-billed duck is here to stay. Our records are in red dots. So it's found in the west and south of the island. It closely agrees with the eBird distribution. So it looks like the bird is back, and it is here to stay. Now I saved the best for last. I recorded a new bird for Sri Lanka. I'm very happy to report the common swift, which is anything but common in Sri Lanka. It is a swift that looks very much similar to the common little swift. It's common with a little c. It's called the little swift, but this bird is the common swift with an uppercase C. Notice that they are pretty similar, but there are some differences. We believe that this bird is probably being overlooked as common swift. The fact that I was 120 feet up in the balcony was of great help because I saw the swifts at almost eye level, flying around. So that greatly helped in getting these photographs and all that. When we wrote it up, we saw that there were quite a lot of discrepancies in the literature from Maldives, which is our neighboring country, small bunch of islands to the west. So we documented all those discrepancies and we published the record, Pavan and I, with lots of photographs. One thing that we wrote in our paper is, most birds, they fly north to south, right? Like in North America, they breed up north and they fly straight down south. But in the Indian subcontinent, there are some birds, about 5 or 6 species, that do this weird cross-continental arc-shaped migratory route. And that's what they think the common swift is doing. But based on the fact that there are a few records in India, and with our new record from Sri Lanka, we guess that this could be happening as well. That at least some birds are flying right through India and Sri Lanka on their way to Africa. And that we suggest that as a possibility, and we alerted the birders to look for them. With that, I finish. I'm thankful to the United States State Department for the Fulbright fellowships, my institution. Sunita Gunavikrama was a wonderful host of the University of Ruhuna. All this would not have been possible without her. Cornell's webcams, the local biologist in Bermuda, he's such a nice guy. Dr. Stevenson in Fayetteville, who gave us the permits to import these fungal specimens. And my good friends Modita and Pavan. I mean, I wouldn't just have known the balcony birds, but Modita and Pavan opened up Sri Lanka for me. Sri Lanka is such a wonderful, hospitable country. I strongly recommend you to not just go birding or whale watching there, but also consider it for retirement. You know why? That balcony, that bungalow I showed you, that house that we lived, guess what our monthly expense was? All included, all included, TV, utilities, food, everything, $600. We lived in sheer luxury for $600 a month, at least for that. Consider Sri Lanka. Thank you.
Wonderful. Thank you, Kannan. So again, if you have questions, feel free to take yourself off of mute or to put them in the chat. And I will relay questions from the chat to Kannan. I'll get us started. So how do the Bermuda storm petrels see in the pitch black in their burrows?
Good question. It is thought that they have extremely sensitive corpuscles in their beak. And that's probably how they sense their way around. That combined with some good olfaction. Seabirds have good sense of smell when compared to other birds. It is thought that that's the way they do it. But a lot of this is still a mystery. So it's a very good question, because that burrow must have been pitch dark. You never saw it groping in the dark. You never saw it stumbling around. It knew exactly what it was doing. So it is stunning that they are able to do that.
So it knew exactly where that egg was to bury it. Had that egg burying behavior been documented before the webcam?
Never before. Never before. Wow. To the best of my knowledge, not in this species at least. And also that kick it did, the backward kick to toss grass above its body onto the egg. I don't know. That seems to defy the laws of physics to me. The only creature that has done something like that is the leatherback sea turtle in Trinidad. So I was amazed when we got footage of that. In fact, if the paper gets accepted, I am hoping that the journal will put that in the cover. That'll make my day.
Peggy Higgins asked if Sri Lanka has notable game birds.
Well, let me think. There are partridges and quails, but they're not hunted that often. There are hunters that go after the more juicy meats like the knob-billed duck. They're worried about hunting pressure on the ducks. But I'm not familiar with quails being hunted there. I may be wrong. Yeah, there are partridges and quails. And the peacock is very common in Sri Lanka. And it's considered a nuisance by farmers.
Dr. Kannan.
Yes, Timothy. Good to see
Hey,
you.
good to see you too. I heard a lot about birds, but did you see any tigers this time?
No, Sri Lanka does not have tigers. It has leopards.
Okay.
Right. But my tiger encounters were in the Western Ghats of India, where I showed you, right?
So speaking of that knob-billed duck, do you think they were just hanging on somewhere where no one noticed them, or do you think they just recolonized from India?
I think they recolonized from India, because if you look at the eBird distribution, just across the Park Strait, there are some good populations in the coast of southern India. So we think they go back and forth. They, after all, fly very well. So I think for some reason in 1960s, they just came back from India, and they are now occupying a large swath of the country, the coastal part of the country.
And
I don't think they can hide for a long period of time. This being such a conspicuous bird, I don't think it would have escaped notice for 50 years had it been hanging in there somewhere.
Roxy asks, why do nootropic birds nest near wasps? What do they protect themselves from?
Ostensibly for protection. It is very common among birds to nest near wasp nests, and they think it is for protection.
From what predators, though? If the birds don't get stung by the wasps, what predators might get stung if they're trying to avoid?
Presumably squirrels, monkeys, they tend to avoid, well, humans, of course, humans too. So protection is the only plausible explanation I'm aware of, or I can think of.
Again, if you want to ask a question, feel free to take yourself off of mute or post your question in the chat. Ishita asks, how exactly does the Bermuda petrel get salt into its bill? Is this because they hunt for fish, or is it because they nest in sand where there is lots of salt in the sand?
Not a bad question from a 14-year-old. I'm proud of you, Ishita. That's wonderful. She's doing a project with me on hummingbirds. So I'm so happy to get that question from Ishita. I'm so proud of her. Well, seabirds eat, the petrels eat a lot of squid. They wander far and wide to grab squid from the waves. They also eat little fish. So they get a lot of salt, and they have to excrete the salts in some way. And one way they do that is by shedding a lot of tears, so to speak. They shed a lot of tears with salt, and that runs down the tube nose and gets excreted that way. That way they don't evaporate right on the nostril and clog the nostril with salt. Good question, Ishita.
Harris asks if the wasps gain any benefits in return for the birds nesting near them.
Oh, Harris is here too. That's great. Harris, we don't know if the wasps gain any benefit because some birds do eat wasps. And so you would imagine that that might happen, but the wasps are not perturbed. The wasps do just well, as you saw in that photograph. There was a whole colony of wasps within a couple of feet of a yellow olive flycatcher nest. But that's a good question. There are a lot of these complex relationships. The extent of mutual dependence among these partners is hard to quantify. Sometimes one partner benefits, the other partner is neither benefited nor harmed. That happens also. So this may be one such example.
And then concerning the birds using the fungal roots, since your two hypotheses did not work out, what other hypotheses do you think may account for the birds' use of the fungus?
You know, I'm glad you asked me that question because I meant to touch base on that. I think sometimes we have to use the simplest plausible explanation. And I think a simple explanation was that it's easily available. It's a common material in forests. Where would a bird like the yellow olive flycatcher get grass material? Huh? Think about that. It has to leave forest patches, go into pastures. I have never seen the yellow olive flycatcher hunting in pastures. It requires pretty dense cover. So maybe we should start there. Maybe there is no smoking gun. There is no magical explanation. It may just be that these black fibers are easily available. But scientists keep testing other hypotheses like anti-carcinogenic. You saw that, right, in my slide? Anti-cancer. How would a bird know? If I use that fiber, I won't get cancer. I don't know. I don't see that as a possibility, but that's one of the hypotheses that has been proposed.
I was thinking it's just a matter of availability too. In Hot Springs Village, they monitor a lot of bluebird nest boxes, and apparently the majority of bluebirds use pine needles because that's what's available. Recently, Carolyn Minson showed me a nest of a bluebird that used entirely grass stems and wondered why that bird used grass stems. And I think it was just that bird came across a whole bunch of grass that was cut and it was easy to get. So it used grass instead of pine.
That's a good point. In pastures in Costa Rica, there is a flycatcher that picks hair from the barbed wire where horses have been rubbing their butts. So the horse hair gets stuck on the barbed wire. And so I found an entire nest made of horse hair, horse tail hairs. I don't think that bird, it's opportunistic. It was easily available, so why not?
Any other questions for Dr. Kannan? Do you think that the color of the fungal strands may contribute to the camouflaging of the nest?
Actually, Dan, these black nests are so easy to spot. We got such a lot of nests by walking around. Even while driving, we would say, oops, black nest, oops, another one. Because they're not camouflaged. They're jet black. And so they stick out like a sore thumb. So that's another intriguing thing that one can explore. You know, how come the bird is choosing this fiber when its nest is so conspicuous? When camouflage is the name of the game for many other species. Intriguing. I mean, I can think of PhD level research on this, on the ants, the wasps, the acacias, the fungus, the bird. Try to tease out some of these relationships. That's very hard. So complex.
Yeah, I agree with Chuck and Ruth Anderson. It is fascinating, and there's so many questions out there, and you have such an amazing mind for thinking of questions to ask from your observations. And I think it's Louis Pasteur who says, chance favors the prepared mind. And I don't think I've seen a more prepared mind than yours, Kannan. So I admire you and appreciate you. And thank you for sharing your research with all of us. And thank you everyone for attending tonight.